Hello students, this subject name is Electromagnetic Fields, in short form is called as EMF. It's a 4th semester subject. The subject code in Anne's regulation EC 8451. Autonomous depends on the college, they'll choose the subject code. This is unit number 5, electromagnetic waves. Electromagnetic wave is nothing application of the electromagnetic fields. Unit number 1 is the introduction part of the electromagnetic fields. Unit 2 is static electric field and Unit 3 is static magnetic field. And Unit 4 is combination of time varying field EM. Then Unit 5, all these 4 units combined, we are going to apply that unit name is called as electromagnetic waves. According to Huygens principle, a wave is in front of the one wave to the another wave of one medium to another medium. The concept, the logic for the general concept of the waves. The very important topic in this unit is normal incidence at the plane of the dielectric boundary. Normal incident, you know the word called incidence. Incidence is nothing but incident wave. Any wave touches to the point, then it going to transmit as well as a reflect. Of the plane at the dielectric boundary, I am going to concentrate on not the conducting boundary, concentrating on the dielectric boundary. See this diagram. The incident wave is represented as I, reflected wave represented as R, transmitted wave represented as T. Since the field strength is electric field, so EI, ER, ET. Where I represent is EI is nothing but electric field of incident wave. I indicates incident. ER is nothing but electric field of reflected wave. R represents reflected. ET is nothing but electric field strength of transmitted wave. Incident wave, reflected wave, transmitted wave. When it was incident, when it was reflected, when it was transmitted. Next, we have two medium. Medium 1, medium 2. First case, medium 1. I am going to take as an electric field as E1, magnetic field as H1. It is a combination of EI plus ER. Similarly, H1, HI plus HR. I'll repeat again, the medium 1 is nothing but this first case, where E1 is nothing but EI plus ER, this EI plus this ER. H1 is nothing but the magnetic field, EI plus ER, similarly HI plus HR. Come to the medium 2, ET, only one medium. So directly I am writing here, E2 is equal to ET, H2 equal to HT, directly. So equate as equation number 1 and 2, equate as equation number 3 and 4. This is second medium. Now, I am going to apply the boundary condition here. The boundary condition is nothing but the condition is both the transmitted wave are equal. ET1 is equal to ET2, which is nothing but, what is this ET? ET is nothing but E2, right? So, I can conclude that E2 is equal to E1, equation number 5. Now, next step number 2. First, already said this step number 1, this step number 2. Direction focus on only transmitted wave. Therefore, combination of transmitted wave is nothing but combo of incident wave plus reflected wave. ET is equal to EI plus ER. Similarly, when you are writing for electric field, parallelly write for the magnetic field. Instead of ET, write HT. HT equal to HI plus HR. Equation number 6. So, I have equation number 1 and 2 in terms of E1 and E2. I have equation number 3 and 4 in terms of E2 and H2. I have the equation number 5 based on the boundary condition. I have equation number 6 based on the transmitted wave, both the electric field strength as well as the magnetic field strength. Now, the intrinsic impedance of both electric field and magnetic field strength, the wave equation is neta, that symbol is neta. Neta is nothing but efficiency, that in terms of transformer, the neta indicates the intrinsic impedance. Impedance is nothing but the ratio of the electric field divided by magnetic field. E is equal to, neta is equal to E by H. What about E? E equal to neta into H. Okay. Now, this E becomes in term of incident wave, in term of reflected wave, in term of transmitted wave. So, I can write as EI, ER, ET. So, EI, when I write I, neta 1 with respect to HI. When I write R, neta 1 respect to HR. When I write T, neta 2 respect to HT. Why this reflected wave is minus? Since incident and reflected both are same. So EI plus ER equal to 0. Therefore EI equal to minus of ER. So it indicates as a minus. So equation number 7, 8 and 9. Once 1, 2, 3, 4, 5, 6 over, I have calculated the 7, 8, 9 based on the neta formula. That is nothing but E vector as well as the H vector. Then substitute this all the 7th equation, 8th equation, 9th equation by using the 6th equation. Et is equal to Ei plus Er, Ht equal to Hi plus Hr. So replace that. Therefore, Et by neta 2 is equal to Ei by neta 1 plus of Er minus neta 1. I am replacing here. What is Et from the 7th? What is the Et from the 9th equation? Neta 2 into Ht. Right? So I am taking all these, substitute the 6th equation. What is Ht? Ht equal to Et divided by neta 2. What is Hr? Er divided by minus neta 1. What is Hi? Ei divided by neta 1. Take all these and directly substitute the 6th equation. I am getting the new equation called 10th equation. Add 6th equation as well as the 10th equation. Similarly, subtract 6th equation and 10th equation. When you add, you will get Ei answer. When you subtract, you will get Er answer. From this, Ei answer is Et by 2, neta 1 plus neta 2 by neta 2. When you subtract, Et by 2, neta 2 minus neta 1 by neta 2. Then, the very important two coefficients you need to calculate in this incident wave. One is called as transmission coefficient, other one is called reflection coefficient. What is this transmission coefficient? The symbol is called as tau. Reflection coefficient, the symbol is called as k. The transmission coefficient is nothing but Et by Ei. Any transmitted field strength divided by the any incident field strength. Therefore, Et by Ei is equal to 2 neta 2 divided by neta 1 plus neta 2. I am taking as the equation number 11. Here the reflection coefficient, the symbol is called as k, I already said, where k is equal to Er by Ei, which is equal to k is nothing but neta 2 minus of neta 1 divided by neta 1 plus neta 2. So we need to conclude by this topic by saying that I have calculated the incident wave and I have calculated the reflected wave. Here this topic belongs to important 13 mark and 15 mark question you can expect in part B as well as part C. Apart from this, you have a 2 mark problem based on the transmission coefficient as well as the reflection coefficient. Especially they will ask the 2 mark definition also. What is meant by reflection coefficient? What is meant by transmission coefficient? The symbol is called tau, the symbol is called as k. The k indicates Er by Ei, the tau indicates Et by Ei. So both the denominator is incident wave. For the reflection coefficient, the numerator is reflected wave. For transmission coefficient, the numerator is transmitted wave. That indicates that Et by Ei, Er by Ei. Hope you are clear with this topic. In unit number 5 in electromagnetic field subject, normal incidence at the plane of the dielectric boundary. So I am just concluding before this topic. Draw the diagram with the boundary of two medium. One medium is purely transmitted medium, other medium is incident with the reflected medium. Then indicate the construction of the diagram, then represent what is Ei, Er, Et, similarly Hi, Hr, Ht. Then write the case 1, case 2 of medium 1, medium 2 equation, apply the boundary condition, then substitute the neta is equal to E by H and find out all the parameters. By adding the equation, by subtracting the equation, we will get the transmission coefficients as well as the reflection coefficient. We have one more topic based on the same concept, normal incident at the plane boundary, same like normal incident at the plane conducting boundary. Since it is a plane boundary, plane dielectric boundary, the boundary is in the medium of dielectrics. The dielectric is nothing but in term of the, according to Height book, epsilon r, that is epsilon, in term of k, constant has been used here, right? All the waves are incident flow towards in one direction, either clockwise or anti-clockwise. Here the topic consists in the diagram. It mentions that the flow is always flow from the left to right direction. It shows that the waves are moving from one medium to other medium from only one side. Okay. So also this topic based on the application for the antenna wave propagation. All the waves are represented only by the propagated in the direction. Hope you understand this topic. Thank you.